titled The Population Data Buffet, Choosing the Right Data for Your Project. Dr. Kugler joined the Minnesota Population Center at the University of Minnesota in 2011 as the project manager for Terra Populus, known currently as IPUMS Terra. She now works across all of the aggregate-spatial IPUMS products, Terra, NHGIS, GeoMarker, and as well as managing their newest product, the International Historical Geographic Information System, IHGIS, which includes aggregate data from population and agricultural censuses around the world. Dr. Kugler's educational background includes a BA in theater arts, BS and MS in systems engineering, and a PhD in geography. The unifying thread that runs through these disparate degrees is an interest in the big picture and how all of the pieces of a system fit together and interact with each other. At the MPC, she leverages those skills to develop workflows and processes to bring different types of data together. And she has developed workflows for boundary processing that meet requirements for confidentiality and harmonization over time, while providing the greatest possible level of geographic detail. She has also developed workflows for documenting and manipulating highly heterogeneous published census tables to conform to a standard data and metadata structure, which is very difficult to do. So we are thrilled to have Tracy with us today, and I will hand things over to her to get started.
All right, thank you, Melinda. Thanks for that introduction, and it's great to be here, and welcome to everybody. And so, as Melinda mentioned, my presentation today is the Population Data Buffet, and that is kind of in recognition that we have a lot of great population data available of different flavors, you might say, thanks to IPUMS and the PopGrid Collaborative and other research projects that are working to kind of assemble all this data. And so we have the happy problem of maybe wondering which type of data is best for any particular project. And so I'm going to talk about three major types of population data and kind of compare and contrast them with the idea of kind of helping you decide which data is best for any particular project. So I will be talking about area level data, so data describing places where each record is a geographic place, microdata, which are individual and household level records, and gridded population data, where you have a raster representing population data, essentially. And for each of those three major types of data, I'll just give a description of what that data structure looks like and kind of how it's constructed, talk about the advantages and disadvantages of that particular type of data, describe some sources where you can go to get those data, and then talk about a couple of research examples, the kind of work that you can do with each of these types of data. And then at the end, I'll wrap up with a little bit on IPUMS Terra, which kind of works across all three of these different data structures. So we'll start with area level data. And area level data is probably, I would guess, the most familiar to most of you. It's simply tables of data by, in this case, counties in Latvia in 2011. So you have each row is a county, and then you have some population data about that county on that row that usually summarizes the population that lives in that place. So here we have information about migration and the place that people lived a year before the census, whether that was in the same house or all the way to somewhere outside the country. And each of these places can then be linked to a set of boundaries on a map so that you can do choropleth maps and other things. Some of the advantages of area level data are that it's familiar and relatively easy to work with. You usually don't get a huge number of records with population data. You might have a few thousand census tracts or something that you're dealing with, but it's nothing that you need particularly specialized software or techniques to deal with. You can often deal with area level data in a spreadsheet, Excel, or something like that. It's also widely available. So for pretty much every country in the world, you can, if you look, go and find published census results that are area level data of some sort. It's good for spatial analysis and mapping. It links to geographic areas, and you can often get very fine geographic detail. In the US, you can get down to census block data, which are what you would think of as kind of blocks on the ground. In other places, you can get enumeration data, or some countries are publishing data at grid cell levels. That's, I think, particularly becoming common in many European countries. And we'll see later when we talk about microdata that fine geographic detail is not available in the microdata. And then the last thing I wanted to mention is that for census data, the area level data are based on 100% counts, and that becomes kind of key when you're thinking about other data that are sample data. So you have to deal with statistical inference and making conclusions about the population from a sample. Whereas if you've got area level data from a census, you have 100% count backing up that data. So you're covering the whole population. Some of the disadvantages of area level data are that you're limited to whatever tables the statistical office decided to publish. So if the statistical office published data on education by occupation, then you might have a table about that. If they didn't, then there's no real way to get at that cross tabulation. The boundaries change over time quite frequently, and that's particularly true as you get to finer scales of geography. So generally, like first level units, states, provinces don't change that much, but as you get to counties or cities or enumeration districts, those change a lot over time, so that complicates things. And just because you have population data does not mean full population data doesn't mean you're free of kind of statistical problems. So because you're looking at the data for an entire population in a place, you have to be wary of making conclusions about like individual people in that place. So the ecological fallacy of thinking that you can know something about specific individuals or types of individuals just from knowing something about a place. You also have the modifiable area unit problem, which those of us who have been through any kind of geography training kind of know very well, where the specific boundaries that you draw around a place, you might draw different boundaries and come to different conclusions. So with all of that in mind, some of the key places to get area level data, and you'll notice that there's a strong IPUMS thread through this presentation. I'm a little bit biased. So NHGIS is our source of US area level data. And we have US decennial census and American Community Survey data all the way back to 1790, which is when the first census was taken. Tract level data start becoming available in 1910. All of the data include linkable GIS shapefiles. So there will be a code in the data table that matches to a code in the shapefile. So you can do an easy join and start mapping your data. And NHGIS also has additional data sets on, we've got some fertility and mortality data. We have some agricultural census data. We have some religious data, survey data. There's some county business patterns data and so forth. So there are other things beyond just the census data in NHGIS. A couple of key features of NHGIS include geographic standardization. So we do high quality estimates based on block level data, mapping 1990 and 2000 data values to 2010 geographic boundaries. So that's addressing this boundary change over time issue. So that's for 2010 tracts. It's also for places, named places, and several other geographic levels. And we'll be extending this to 2020, kind of as soon as we have the 2020 data available. We also have time series tables, and those are tables, data tables with consistent categories over time. So as the census kind of changes what they publish from census to census, you might end up with, and this is particularly, comes up a lot with age data. So you might have different groupings of ages. And we've kind of gone through and done as best we can to harmonize that so you get a consistent set of age groups over time. And the same goes for some other types of categorical data as well. Okay, and then on the international side, as Melinda mentions, I manage the IHGIS, which is our newest IPUMS data product. We just launched our web data access system last October, so we're just over a year old in terms of having data out to the public. IHGIS has population and agricultural census data, and the agricultural census data are kind of fun. They include information on crops planted and harvested and yield, as well as inputs, so labor and fertilizer and irrigation and farm machinery and all kinds of stuff. It also has data on livestock, so there's a lot of data in there. As with NHGIS, we provide linkable GIS files for our IHGIS data. Right now we have, I believe, 22 countries, and that's growing. So we release new data several times a year. And most of the data in IHGIS right now are 1990s and later, because we're limited to, at the moment, we're limited to data that is available, at least in PDF documents that we can copy and paste easily. We did just get an NSF grant to extend to include data from print documents that involves optical character recognition as kind of a pre-step to all of this. So that kind of older data will be coming down the pike in a few years. And we don't have, we're a newer project, so we don't have kind of the bells and whistles that NHGIS has, but our key kind of reason for being is to take all of these data tables that are published mostly in PDF documents by statistical agencies, and they come in every possible structure that you can imagine for a data table. If you can imagine it, somebody has done it somewhere. So we take all of those data tables and we transform them into a standard structure. So every table that you get out of IHGIS will have this GIS join column. It will have the geographic units with their hierarchical parent-child relationships, and then it will have all of the data columns, and those are linked to comprehensive and, again, standardly structured metadata files. So you get a human-readable code book. You also get machine-readable CSV files that give you all of the information about table labels and column headers and universes and all of that good stuff. So this is where we have data available and coming soon as of this moment. So the darker colors are what is currently available on the website. Lighter colors are coming in the next few months. And blue is population data, green is agricultural data, and we have a few countries where we have both already. So Finland, Algeria, and one of these Cook Islands, which was covered by your lovely faces. So you see we focused mostly on Asia, Europe, and Africa right now. That's partly because we have particularly good microdata coverage for Latin America, South America, Central America, the Caribbean. We have microdata for almost all of those countries. So we have not focused our data collection and processing efforts for IHGIS on those countries up to this point. And this is kind of a preview of what's coming over the next several years. So all of the countries that are colored on this map, we have some kind of data for. And the countries that are in this kind of teal color, we have both agricultural and population data. Countries that are in blue, we have just the population data. Countries that are in green, we have just agricultural data. And again, some of those are places where we haven't really looked for the population, area level population data because they're covered by microdata. So you can see at the bottom of the slide here, we've got just a handful of countries really where we have not been able to find any data at all. So if you happen to know of data for any of these countries, please let me know. We'd love to have it. And that might be, we might be able to find some of these in the print documents that we'll be able to start working with soon as well. So some of the things that you can do with area level data, this is from a paper by Faber in 2019 that was looking at how alternative financial services are associated with segregation. So they took tract level population data with kind of all the characteristics you can get from NHGIS and related that to addresses of banks contrasted with alternative financial services, so payday lenders, check cashing operations, that sort of thing. And you can see here that they found that in tracts that are not white majority, they are more likely to have a higher proportion of these alternative financial solutions as opposed to traditional banks. And that is exacerbated in metropolitan areas where there's a higher level of segregation. So they needed the tract level detail to get at these spatial relationships between population characteristics and these financial institutions, as well as to get the metrics of segregation that they used to look at kind of what was going on at the metropolitan level. Another example, this paper looked at places that had been consistently integrated. So looking at places that have kind of a balance of white, Black, Asian, other ethnic groups, and trying to kind of figure out what are some of the characteristics that these places that remain persistently integrated have. So they were looking at 2000 and 2010 data. They used the NHGIS geographically standardized data to look at places. And so these are named places. So you can think of individual suburbs or towns. So that was kind of their unit of analysis is a place that is kind of recognizable to the people who live there. And then they also use block level data to look at metrics of integration, looking at spatial patterns within those places of where different population groups lived. So they found that one thing that's not shown in this figure is that most of these persistently integrated places tended to be suburbs rather than central cities. And then they also found that it was a strong indicator if the kind of economics of the place were kind of federally supported employment centers. So universities, public sector, military. So that's kind of an interesting finding. All right, moving on to microdata. So microdata are individual records and household records. So on each row of the data, you have one person's response to all of the questions that were asked in a census or on a survey. So you have marital status, age, school attendance, educational attainment, employment status, ethnicity, religion, income, whatever might be asked on a census. And people are grouped typically into households. So you can get an idea of household structure as well. So in the person records I have here, you've got kind of a one person or a two person household here, two 20-something men, maybe roommates, maybe brothers. And then you've got older couple, or actually they're both female, so there's maybe they might be sisters who have come to live together later in their lives. And then you've got kind of a larger family household here. And then you also have household level information. So you have information about the type of building, what it's constructed from, the ownership, how many bedrooms it has, water supply, lighting, phone, various amenities and utilities. So all of that is kind of at the household level, and you can get that attached to the individual level data. So you would have kind of the same household level information for each person in the household, or you can just look at the households themselves. So the advantages of microdata are that it's extremely flexible. So because you have the individual level data, you can do whatever tabulations you want to do. So you can cross-tab anything that you're interested in. You can cross-tab ethnicity with religion, with educational attainment. And that probably wouldn't be a table that's published by the census office, but you can get it from the microdata. You can also use the individual level data to do individual level regression and analysis, because you know exactly for every person what their characteristics are. So you can be confident, you don't have to worry about that ecological fallacy problem. You can be confident that if somebody is 16 years old and is working in a particular type of job and has a particular type of education, that those things have something to do with each other. You also have information on household structure. So you can look at relationships within households. You can look at children with respect to their mother's education, or you can look at husbands and wives and their respective employment statuses. And there's a lot of really cool work that has been done taking advantage of that household structure. The disadvantages on the flip side, and you'll see these are kind of complementary to the area level data. So whereas in area level data, you can get down to pretty fine geographic levels, for the microdata, because they are individual level data, in order to protect confidentiality, we're typically restricted from releasing very fine geography. And I've got some illustrations of what that looks like in a little bit. Microdata are also not available for all countries because they require specific agreements with the statistical office to get access to those data in most cases. So IPUMS International has done a phenomenal job of getting these agreements with countries around the world. They have about 100 countries that we have agreements with, but that's still less than half of the 200 plus countries that exist in the world. They are sample data, so you'll get anywhere from like a 1% to typically a 10% sample, depending on the country and the year. So that can sometimes limit your statistical power, depending on which types of populations you're looking at. And you also have, in many cases, you have a lot of records to deal with, because you're dealing with individual people. You can have up to millions of records to handle. And that requires some specialized software and specialized skill to work with that bulk of data, although that is getting a lot easier and less complicated. So I mentioned the geographic detail contrast between microdata and area level data, and this is kind of an example. This is the Twin Cities area, showing in green the public use microdata areas. So those are the smallest geographic units identified in the microdata. And in the US, they're required to have at least 100,000 people in those units. And the blue are census tract data, and you can get pretty much every table in the census results down to the census tract level. So you can see how many census tracts are kind of packed into the PUMA level data. So you can get, if you're trying to do any kind of spatial analysis, you're kind of hampered if you're working with the microdata. And the same holds in international contexts. For IPUMS International, our standard agreement with statistical offices is that the units that we release in the microdata have to have at least 20,000 people. And that's smaller than in the US, but it still has some restrictions. So this is the Dominican Republic. And you see in the green are the original municipalities. So that's the second level administrative unit, kind of the county equivalent. And there were 156 of those. But to protect confidentiality for the microdata, we have to do what we call regionalization, which is group municipalities with neighboring municipalities to meet that 20,000 person threshold. So there's 93 of those, and you see we lose a fair amount of geographic detail, especially in the western part of the country over here. So IPUMS has two microdata products. We have IPUMS USA and IPUMS International. IPUMS, both of those products have microdata with the variables harmonized over time, and in the case of IPUMS International, over places as well. So microdata records are typically coded with numerical codes for different categories. So you might code 1 as male and 2 as female, or 0 as female and 1 as male or something. So IPUMS has coordinated all of those codes over time so that you don't have to deal with all of that messiness. And that gets more complicated for like marital status, where you might have different categories that are used in different places. So we have kind of a lowest common denominator grouping that we will do for the harmonized variables. You can still get at the source codes as well. The US, IPUMS USA has US decennial census and American Community Survey data from 1850 to the present. And we also have full count data and do some cool things with that full count data. So in the US, after 72 years, the individual level data are released from embargo. So you can get every single person who was enumerated in censuses 1940 and earlier. So we have individual level data from 1850 to 1940. The earlier censuses only had household level records. So we have every household, but you only get kind of information at that household level, including kind of the number of people and counts by age and sex and things, but it's the only individual record you have is for the head of household. The publicly available data do not have names or specific plate addresses, but we do have restricted versions available kind of upon request and application. So you can get the full strings of names and addresses. Those restricted versions also include the original occupation strings and things like that. One of our newest things that we're working on with the US data are this multi-generational linking panel, where we are constructing links to the same person over time in different censuses. So what we have available right now covers 1900 to 1940, and it will match people from one census to the next, to the next, to the next. So you can get information on where people are migrating to, how they're forming families, how households are changing. So that is kind of very cool data, and we're planning to extend that eventually back to 1850. On the international side, as I mentioned, IPUMS International has over 100 countries and over 1 billion person records. Most of that data is 1960s to the present. Some of the particular other things that are available in IPUMS International, we have some historic full count data for North Atlantic countries. That's typically 1911 and earlier, all the way back into the 1700s in a few places. And then we've recently started working with household and labor force survey data. So we've currently got available labor force survey data for Spain and Italy, and that comes at a higher frequency than the census data does. And we're working on releasing several more of those labor force survey countries in the next year or so. And then I also wanted to mention that IPUMS has a number of other microdata products. These are mostly survey data with various topical focuses. So the current population survey, which is the US labor force survey primarily, We've got a number of health surveys, both in the US and internationally. Higher ed is surveys of the science and engineering workforce that are conducted by the National Science Foundation. So many of you are probably represented in that data set. And then the time use is time diary data from the US and several countries around the world, which records people's time spent in various activities, who they're with, where they're at. It's very cool data that I have not had much of a chance to dig into, but have seen some really cool research using that data. So this was mentioned a little bit earlier on the previous map. This is our IPUMS International current data availability. And you'll see that most countries, we have second level administrative units. Again, those are regionalized, so they might not include every second level unit, but they are kind of at that level. And then the darker colors here are where we have just first level administrative unit. And you'll see that particularly Northern Europe, they have more restrictive confidentiality policies in those places. So we haven't been able to get the finer geographic detail on the microdata. So we're working on that with the area level data in those places. So here are a couple of examples of research done using microdata. So this was a paper looking at how children's likelihood of living with both parents and grandparents has changed over time. So looking at 1940 to 2018. And this took advantage of that household structure that's available in the microdata, as well as harmonized characteristics over time. And so they found that children, there was a decline in living in multi-generational households from 1940 to about 1980, and then it started ticking back up since then. And one of the interesting things that I found from this paper was that they found that in the earlier time period, mothers' employment in the labor force was more likely to be attributed to, or more likely to be associated with multi-generational households. And now it's in the 1980 and forward, it's less likely to be associated with living in multi-generational households. And then in the international context, and here an example was looking at the likelihood of not living with one's spouse, so marital non-cohabitation. So this is looking at kind of labor migration and whether or not the spouse comes along or not. So this was looking at data harmonized over 70 countries, so really taking advantage of that. And again, looking at the household structure and all of these individual level covariates. So this is female and male migrants, and you'll see that the likelihood of not living with one spouse increases as GDP increases. So that kind of indicates, I think, that in countries that have higher GDP, they're more likely to be receivers of people who have come looking for work and left their spouse behind. And the likelihood seems to be higher for these kind of lower level occupations and lower as you get kind of towards the more educated, more skilled occupations. All right, and finally, gridded population data, which is not something we do a lot at IPUMS, but we know people who work with it. So gridded population data are essentially rasters or images of population counts or densities. So you'll have a regular grid of cells. I think these are generally 250-meter cells in these data sets, where each cell has a value that is either the number of people in that cell or the population density for that cell. They're kind of interchangeable. And these data are generally derived from area level census data, but then there's some kind of processing that the research team does to get it into grid cells. So generally speaking, that's a dasymetric technique. And the simplest version is to kind of mask the population data to areas where you expect people to be living. So whether that's based on terrain or environmental characteristics or known places of settlement, or kind of sometimes people will use the nighttime lights data to figure out where people are, and then just only assign cells in those populated places the population. So just kind of masking out unpopulated areas. And then you can get much more complicated with that, where you bring in multiple layers of information. So that might include road networks or nighttime lights or terrain or land cover, or even kind of cell phone data or a variety of different data sources, and use that to weight different places and then distribute the population from the area level census data according to those weights. So you get a kind of modeled gridded population. The advantages of gridded population data are you get very fine geography, so often sub-kilometer geography, which means that you can then aggregate those back up to any kind of geographic units that you might want. So you can do kind of political boundaries, or you can do watersheds or any other type of geographic unit that you want to analyze. You have regular geographic units, so you don't have to worry about boundaries changing over time. It's always just these pixels. And most of these data sets have near global coverage. So they've been able to find some kind of population data somewhere and then model it using whatever techniques they're using to distribute it to the grid cells. The disadvantages, primarily, most of the gridded population data sets have a very limited set of characteristics. So in the area level and microdata, you can get education and employment and race and ethnicity and all of these things that are asked in a census. Gridded population data tends to have total population counts and sometimes counts by sex or age. It's also modeled or interpolated data, so you run into questions of endogeneity and how confident are you that the people are actually in these places. And so that really depends on what you're asking in your research. There are a number of different sources of gridded population data that differ by essentially how they distribute the population to the grid cells and how highly modeled that is. And the PopGrid Data Collaborative has been active over the past several years, kind of collecting these data, so they're all available. You can get to them all from the PopGrid website, and they also do a good job of doing these comparisons and contrasts across the different data sets. So the gridded population of the world is not modeled, and that's intentional to kind of avoid these endogeneity problems. So really they're just taking the area level data at the finest scale they can get to and distributing it evenly over the grid cells in those places. And then that kind of goes all the way up to Landscan and WorldPop, where they're bringing in all kinds of different ancillary data sets and pretty heavily modeling. So you get sort of a more realistic looking picture of the population, but then it's all kind of made up, but made up intelligently. So this just shows some of the differences across these different data sets. So depending on kind of what your focus is, you might want to balance or choose one or more of these data sets to work with. Some research examples using the gridded population data. So these will tend to look at these spatial distributions of populations. So this was a paper that was looking at how reductions in particulate matter pollution in China have affected premature mortality. And there was a policy that went into place in, I think, 2012 that was intended to really reduce particulate matter pollution. And so they're trying to figure out whether that has been associated with reductions in premature death. So they took the particulate matter concentrations, which they have monitoring stations, so they have a spatial distribution of those concentrations, and combine them with the gridded population of the world population distribution, and then use that to kind of model and analyze premature deaths across space. And they did find that there has been a reduction in premature death that can be attributed to these reductions in pollution concentration. And then another example, this is kind of doing more of an extrapolation type analysis. So this was looking at which vaccination strategies are most effective. And the researchers took demographic and health survey data. So that was surveyed at particular points in these countries. And they were able to take the vaccination rates that they knew from those surveys and correlate those with spatially dependent correlates, so distance to nearest large city and particular population density variables and distance to roads and things like that at each survey location, and then use that in combination with the gridded population data to extrapolate vaccine coverage across the whole country. And they found that, so the measles and the DTP3 had kind of different vaccination strategies. One, and I forget which one, had more kind of routine immunization, and one was kind of focused on these specific outreach efforts. And they found that the outreach efforts were, in many places, effective at increasing vaccination coverage in places where the routine immunization was maybe not getting as good a coverage. All right, and then I'll just wrap up with a little bit on IPUMS Terra, which was my baby for a while, and Melinda worked on it as well. And that was a project that integrated raster data, area level data, and microdata using location-based integration. So our data access system allows you to choose which data structure you want to get your output in, and then you can pick input from any of those three data structures and kind of transform it to the structure that you're interested in. So we would take raster data and summarize it to area level units, or take area level data and distribute it into raster grid cells. We take microdata and tabulate it to area level units, or we'd attach area level data to microdata records. And the data collection that IPUMS Terra has is, we have population data, we have microdata from IPUMS International, and then we have area level data, which we've tabulated from IPUMS International. So we have a set of standard tables that we construct from the microdata. We also do population by sex for countries that aren't available in IPUMS International. And that was kind of the instigation of what has become IHGIS, was looking for that additional population data. We also have environmental data on climate, land cover, and harvested area and yield by crop. And IPUMS Terra, the web data access system is still available. You can get these data, you can do the data transformation. But unfortunately, data at this point. So with that, open it up to questions, comments. Again, IPUMS International, or IPUMS, it's not just international, is at ipums.org. You can email us at ipums@umn.edu, or you can reach out to me directly if you have questions.
Awesome. Thank you very much, Tracy. That was a very helpful review of what is a very complicated set of resources. So we do have time for questions. So please add them in the chat and I can read them to Tracy, or you can raise your hand if you'd prefer to unmute. All right, well, I have a question, if nothing else. So you were talking about for IHGIS that you're transforming many different types of data tables into a more standardized format. And I guess I was just wondering, like, what does that process look like? That seems like a really complicated thing to do. Like, what types of tools are you using? Like, who's involved in that?
Yeah, thanks. That is a great question, and it is complicated. We have the philosophy of IHGIS overall is to let computers do what computers are good at and let people do what people are good at. So we have developed this process that relies on what we call a markup framework. So we take all of these data tables that we get from PDF documents or sometimes as Excel tables. We bring them into Excel, which we use as kind of an interface, and we tag the data tables in Excel with, and this is kind of a manual process, so we have kind of a team of undergrads that work on this. So they will mark, this column has geographic unit names. This column or this row has headers related to sex. There's a column here that has headers related to education. And then they also note the universe of the table, where the title is, if there's any footnotes, and of all of the structural information, so that we have a software tool that will take that marked up table and use those tags to guide ingest of that information into a database. So it would be really complicated to write the software to figure out where all those bits and pieces of the table are. It's pretty easy for people to look at it and kind of quickly do this tagging. In some cases, it's not so quick because the tables get weird and complicated, but we are almost always able to tag them in some way eventually, and then we can ingest them into the database. So we have all of the column and row headers organized. And then we have additional software that we can, if we need to, we can restructure the data. So if we get data that are, like you get a place and then you have urban and rural, and another place and urban and rural. And our final data structure just has one row for each place. So you can easily connect it to a shapefile in a GIS. So we take those urban rural and we make additional columns out of that. So we restructure it. And that's something that we have our software do, because you don't want people doing that. A, the people don't want to do it, and B, they're going to mess it up. So it's safer to let the computer do that.
Cool, thank you. Any other questions for Tracy?
I've got a question. There's so many things that the group that Minnesota Population Center works on. How do, it seems like I'm always learning about something new that's happened that I'm like, oh, I have to go check that out. What is the size of the staff, and kind of like how it feels like you guys must be really projecting out pretty far with a lot of these products. Like you have things in your slides about like, oh, we're going to be extending this thing back to 1850 and whatnot. Maybe just describe a little bit how that works and so successfully, it seems.
Seal approval. We've been putting a lot more data on our IPUMS.org website about kind of things that, how we work as a center. So we now have information there about all of our current grants and our staff and everything. We do have, I think we have close to 24 active grants right now. So we're constantly in a kind of grant renewal proposal writing cycle. We generally work on mostly 4 to 5 year grant cycles. And as we come up to the end of one, we're writing the proposal for the next one to keep that product going. So we're always coming up with ideas of what should we put in our next grant and how are we going to keep this exciting for the funding agencies. And we have kind of we're kind of structured with area level data and microdata. And then we have an IT support staff. And I think we have usually somewhere in the neighborhood of 50 to 60 full-time employees and about that many working on these projects.
That's great. Okay, another question. What kind of collaboration do you have with Ancestry.com and Family Search again?
Yeah, so that collaboration was and is working on the full count historical US data. So Ancestry and Family Search have interest in kind of digitizing those data for their genealogical products. And we've been able to partner with them to kind of support some of what they're doing. And in return, they'll digitize some additional variables that we're interested in that aren't necessarily as useful for the genealogical research, and also allow us to access and disseminate certain parts of the data. So that's part of the reason that the publicly available data don't have the names associated with them, because Ancestry is kind of, that's their business model, is letting people search by name. So that's a restricted piece of our agreement with them. But we've worked with them to do a lot of the kind of data entry and digitization of those individual census records. And we are right now working on a proposal for the 1950 full count data, which will be released next year. So we're hoping to get to work with that as well.
Exciting. I think we have time for one more question, if there is one.
I have another question. You noted that the Northern European countries had more restrictive privacy practices around the microdata and the geographic levels. Do you think that they are maybe being overly cautious that other places don't have that same privacy, or are they ahead of the curve on the privacy there?
That is a great question. And we've actually been talking a lot about confidentiality protection as the 2020 census round in the US has been going. And there's been a whole sea change in how that's going in the US, even for the area level data. So I think that it's partly driven by the populations in those countries just being kind of privacy as a thing that they worry about more. And so there have not been cases of data breaches with census data that kind of have caused huge problems. So I think it's an anticipatory concern, but it's, and kind of on the flip side of that, the Northern European countries and these countries that don't want to let their microdata out. So we don't think we'll ever get a microdata agreement with Australia, for example, because they just like, no, it's not going anywhere. But those countries often have very fine geographic detail in their area level data. So we have, for Germany, we have area level data that goes down to essentially the census block level. And Australia and New Zealand have what they call mesh blocks, which are basically pixels of population data. So you can get pretty detailed data there, just not the actual individual records.